Hello Year 12, welcome to another revision video of Chapter 2, the network concepts, and this one is focusing on question 5 and 6 of the chapter review. Both of these questions are dealing with a minimum spanning tree. So to do this successfully we need to understand a few things. Firstly, what a tree is. So I'll put this little explanation over here to help. A tree. Connected graph contains no cycles, multiple edges or loops. So what are they? Well, a cycle would be something like this, where you end up at the same vertex you started. That's a cycle. Or it could be anyway, start with B, go around, end up back at B again. So there's our cycles. Multiple edges, or let's choose this one. So we go to B to C and then we end up going back again. There's two edges for the same two vertices. Multiple edges, you could go A to E and then back again. That's a double edge. Multiple edges, and a loop is simply an edge that starts at one vertex, doesn't connect to any other vertices and ends up back at the same vertex. So there's a loop. So a tree doesn't have any of that. So we've got, I'll just put this over here, no cycles, no multiple edges, no loops, and that's a tree. The spanning tree part means that it connects all of the vertices. All. Yep. And a minimum spanning tree does all this with a minimum weight. And what I do is it says here there's a couple of algorithms you can use. I tend to go for prims, as that's what I've got used to. So that's a minimum spanning tree, and we're going to use prim's algorithm for both of these. So let me just, now I've got all that there, take that off, and so we can get to and actually do it. So leave all those points there just to remind us. Now with a minimum spanning tree, it doesn't matter where you start, but what I do is I put all the vertices. It's not so bad when you've only got a few. When you've got a few more, it's a bit more crucial, but I list all the vertices so I know we've covered them all. So with prims, in fact I like to start alphabetically, but it doesn't matter. But I'm going to start at A to something. Now what you've got to do is have a look at all the edges that come off A and find the one with the least weight. And we've got a 10 going that way, a 7 going that way, and a 6 going that way. So A to E is the least weight. A to E has a weight of 6. And so that's the one we're going to do, A to E. So now I'm just going to fill it in so I know I've done it. A is covered and E is covered, so you keep a check of which edges you've done. That looks a bit messy there, I might just redo that. A to E. There we are. So now we check out vertices A and E both, or all the vertices we've used. We have to find the edge that comes from them with the least weight. So going back to A, we've still got the 10 going this way and a 7 there. And from E, there's an 8 there and a 7 there. So we've got two edges of the same, so it doesn't matter which one. So I think I'm going to go with the A to B one. A to B, which has a weight of 7. A to B. Now so far we haven't got any cycles, and we haven't got any multiple edges and no loops, and we've got 3 of the 5 vertices covered. Okay, now we're going to check out A, B and E. Where's the one with the least weight? And I've got a 10 here, 5, 6, 8, 7. Well, it looks like 5 is the least weight going from B to C. That's the one we'll do. B to C has a weight of 5. So let's go there. And now C is covered. So only got one more vertex to do. And when you get to this point where there's only one left, choice is pretty easy. We've got the 10, 10, 6, 8 or 7. So I'm going to go with the 6 because that's the least weight. B to D. D is now covered. Up. B to D. And that was a 6. And the total, because you've got to determine the length, the total is 13, 18, 24. There's the answer. The length of the minimum spanning tree is 24. Okay. Question 6, doing the same thing. So I'm going to go alphabetical again. What does it get up to? G, D, E, F, G. Okay, a few more vertices, so a little bit more tricky. Let's go with finding from A the least weight. We've got 2 off A, and the least weight is obviously A to C. Has a weight of 8. A and C are covered, and A goes to C. Okay. Now, using A and C, we've got a weight of 20 there off A. For C, we've got a 10, a 4 and a 40. I'm going to stay right away from the 40. Looks like C to D is the go with 4. So C to D with 4 is the least weight of all the choices we've got. C to D, and the weight is 4. So now we've got 3 of the edges covered. Got 4 to go. Now coming from all of those, A, C and D, we've got a 20 from A, a 40 and a 10 from C, and D's got 35, 30 and 5. Well, pretty easy. D to B is the one we're going to go with because that's only got 5. D to B, and so far we haven't got any cycles, multiple edges or loops, so that's all good. Alright, check off B, and we're going D to B, and that has a weight of 5. Okay, so now we're choosing from A, B, C and D, where I've got a 20, a 10, a 40, 30, 35, 20. Well, we could do the 20 from B or the 10 from C. That's the least weight of all of those. However, when you go C to B, that creates a cycle. So we can't use that one. So I've got to find another one. So next up from 10 is 20. I think 20, 10, 20, 30, 35, 40. Yep. So I think it looks like the 20 is the next one, but we can't do this one because there's another cycle when you go B back to A. So it has to be B to E. Yep. So you've got to keep this no cycles in mind. So B goes to E. Here's the next one. E is covered. Weight of 20. and we've got B to E. So now we've only got F and G to go. Alright, of all those, pretty easy to see that E to F is the least weight. E to F, and it doesn't create any cycles. So I think we're all good. E to F. E to F, yep. And that's a weight of 8. E to F. Weight of 8. So now we've got G to get to. And you get it to it from E or F. And looking by the weights of those, 11 is the least weight, so we're going to go F to G. 11. G is covered now. F to G. Weight of 11. Now we just add them up to get the length. 12, 17, 37, 45, 56. Double check that. 19, 39, 44, 48, 56. There we are. We're done. So remember the process. This is really important. The no cycles, model edges, especially that one. No cycles. And also, yeah, got to make sure we connect all the vertices. That's why I do this list here. And as you go, find the edge with the least weight coming off each vertex you're covered. Then you should be able to get there. Thank you.